Okay, connections are very important to your battery. These are insufficient. Disconnected it after 2-hour charge, dropped down to 1.5 volts, wobbled the leads heaps and pressed them back up to 1.9 and on its way down. Just from a little wiggle of the leads. It's a dirty looking old cell, but it's proving to be quite interesting. It never nearly made it to video, or it was on video several times and I deleted them all because it was sort of failing, but it's not really failing. I think it's the lead ends. They're quite dirty. And that one on stainless steel thin wire doesn't sort of help. It sort of rotates and doesn't quite bond. But if you get it, it actually performs much better. I'll explain later what the cell's made out of. Okay, this is the 50th run for the cell. It's not looking good. I think the piece of separator there that snapped off the top, so I've got a spoon, fork holding that sort of in place, the negative electrode. That was just a piece of printer paper, so not very good. It sort of doesn't need the separator, but we only got the separator so the two things don't touch in there. With a larger gap, I'm hoping I can get away with using those hair rollers. That's why I'm trying to make another cell with a larger hole. The separators become conductive like in the 200 ohm range. So I think they're getting coated with nickel hydroxide. That's why it's black. So the cell's performance is suffering due to that, I think, because it's been not too bad for 50 charges. It was up and down. What do we got here? That's the milliwatt column. And you can see where it's sort of not too bad in its results. Here are all the milliwatts. Started off at 144. Went down there, up there, a little bit down, up, down again, down again there, and the other ones haven't been documented. I've just been charging and discharging the cell to see the cycle life. These are the milliamp hours. It needs a 2.7 volt charge though, maybe due to resistance issues. And the leads are getting a bit not so conductive as well, so that's an issue. They need to be, wires need to be soldered onto them. So we'll get back with the results of this and I'll tell you how I made the cell. Okay, making some nickel hydroxide. First you'll need 450 mils of distilled water, 26 grams of nickel sulphate, 20 grams of sodium hydroxide, caustic soda, in 350 mils of distilled water for the sodium hydroxide. So you mix nickel sulphate with a little stir until it's all dissolved. Do the same with the sodium hydroxide and then add the sodium hydroxide dropwise to make fine nanoparticles to your nickel sulphate. So I'll just set that up, get that dissolved. That takes a bit to dissolve, 26 grams in there. That one doesn't take too long to dissolve. Okay, the nickel sulphate's all dissolved. I got the sodium hydroxide in the dripping flask, or the separator flask I should say, but it works as a dripper. I'll start dripping it. You can do it manually, but you'll need it on a stirrer because it needs to be about an hour afterwards to keep the mixture going. And the smaller the drips, the smaller the particle size. So I'll do a time lapse and we can see the chemical change happening. So I'll set that up and I'll get back. Okay, that wasn't too painful with a separating flask to do the dripping. So now it needs stirring for about an hour or two, just to make sure it's totally reacted, and then you allow it to settle, siphon off the liquid, and then you pour some more liquid into it, and then let that settle again. Do it about 3 times and you should have a clean solution, and you just leave it in liquid because we're going to dip our carbon electrodes into it for the positive cell. Okay, as you can see, most of these are too small for a cell. They come broken. I think transporting breaks them up, or if they're not careful with them. That was a good size one. So since I can't use hardly any of them anymore, only that one, I've decided I might start making up a jig. I'm going to go for a larger outside diameter. That will be the in sign, but not the negative shaft. That will be the hole size outside of that. So we're about 12 mil wall thickness of carbon we'll have. And I'm thinking about this tube as the make a carbon electrode for the negative side. I might try if I can find some 15 mil actually, so there's more space between the outer wall and that. There's probably around about 4 mil, probably not enough. I'd like about 5 mil right around the outside of the carbon center core to the outer core. So I'll hunt for something for that. So I have to drill a hole through here so I can weld that down in there without any beads down here, and that thing just goes over there. I might make up some little plates to hold this in, then we'll just pack it by hand with this carbon. I'll use the plier. I'll cross this up, and this has been plied already, and I'll use cornstarch for the binder, and then I'll dry it first in the oven, then I'll kiln them or furnace them at 1000 degrees, and they should turn out like this. Hopefully that's the case. Hoping if they can stay intact at that size, we should be looking at a better cell. Simplicity of it, I thought I might as well just weld that straight to the plate, because at the bottom that's not going to really matter too much. 2 little tacks on the upright. I've got some stabilizing stays where I can probably stick a clamp to that outer part maybe, just to hold it firm. So that will be the outer positive electrode, or I'm going to try a negative big side and an inner core of the positive perhaps too, just to see if they are similar or better, being negative on the outside being larger. So that's that mould. So all we have to do is work out a cornstarch ratio which will hold this carbon together after it's been kilned. It's going to be hard to pack down there, so I'm going to have to find a little rod which I can stick down there and just pack. Okay, hour and a half later I crushed up all of those little briquettes. I got some fine, I did over half of the briquettes with fine sieve, and then the rest of the stuff I had added coarse through another coarser grid. I made some homemade dextrin ages ago out of corn flour and put it in the oven for a couple of hours on 300 or 200. Last time I used it I didn't heat it up, I used cold water, so I got a heating stirrer which was quite cheap, and I've mixed in a heap of that to make a syrup, and I'll let it dissolve and stir up and get hot. That should turn it into a polymer now, where as last time I think it wasn't a polymer because I didn't heat it and the little chains didn't form. So this has been sitting idle now for a while. You can see a double layer there, it should be clear up there, that would be sodium sulphate, and nickel hydroxide will be settling down. You wait for a couple of days and then you can siphon off the top part, add some extra water to clean it. Do that a few times and it's all good to go. Okay, the dextrin should be well stirred. We're at 65 degrees. Looks like it's all stirred up. So I'll put some detergent around the inside and the outside of the pipe. So hopefully it doesn't stick. So I'll start mixing and see if I can actually make one of those carbon briquettes. Okay, that was level with the top of that pipe 10 minutes ago, so it's swelling up. So when it dries out a bit, because I made it a bit wet, I'll pack it down harder. This one here seems to pack down better. You can ram it easier. This one seems to just go sloshy. And that's raising at the top as well. That was about 3 millimeters under the top surface. So it's probably creating little air pockets, which would be good if we could keep it intact. I'll come back later. Okay, a half hour, it's growing even more. It's like I'm forming into carbon aero bar. Wonder if I should leave it like that for a test one, because that's what we want. We want air bubbles all the way through this carbon, but we also want it to be held together pretty firmly. Maybe if I'm gentle enough and get it out of that mould later on and kiln it, or furnace it I should say in my case, as it is, and keep fingers crossed it stays intact. That one's swelling out the top even more too, and sort of at the bottom. Could be reacting with, oh no, I didn't put any dishwashing liquid in this tube, so that's not that. So that's actually grown heaps, 10 mil. Okay, I've decided to leave it in its expanded form because I slid it off, a little bit down there broke off. So I patted it around there, but as you can see in there, if the outside's like that, that's probably what we want. We want porous carbon type foam. Hopefully it holds together, and then when it's furnace it will become really hard. Hoping. I've only got that wastage. I'll make a carbon cookie thing, and then I'll furnace it anyway when I go to furnace this. I compacted that because I need a bit more strength in that rod. So we'll compare the difference. That's been doubly compacted. But it expanded that much, so I'm hoping it's totally full throughout the pipe, no air bubbles. Okay, the nickel hydroxide was left overnight to settle to the bottom. I drained off that much liquid, which should be sodium sulphate. So now you just repeat, fill up with some DI water, give it a stir, let it settle again, and repeat that 2 more times, and you should have some clean nickel hydroxide. So I'll let that settle out. I'll give it a stir in a minute and let it settle overnight, and I'll repeat it tomorrow. Okay, back the next day. Failed with the dextrin, it just turns to powder. I even tried heating it up and it just goes back to that state. It crumbles. So I'm going to use just normal cornstarch. Apparently you've got to bring it to boil, so I'm going to wait for that to boil. I have a half a cup plus 1 spoon in 400 mils of liquid, which raised it to nearly 550 mils. So we'll let that warm up and come to a boil, and I'll try again. And you can't leave it in the mold, it doesn't come out. So as soon as you press it, it has to be pressed as well. Can't leave it light and fluffy, which is a bummer. So attempt number 2, not having much luck. I've been watching tutorials, they make it look easy, but they don't show you if they're solid enough, and they don't have a hole in them. Oh, look how messy this thing just got. Okay, we're at 61 degrees, so I'll keep going until it's the boil. Hopefully that works this time. Hopefully I got enough. It's a half a cup plus 1 spoon in 400 mils of liquid. Of water, because it started getting really thick. So I'm going to overkill. So a half a cup and a spoon. Too much for a small batch. Now I'm not sure if that's going to be too thick or what. Still not quite up to temperature yet. Down like on the glass it sort of is. Depends where you measure it. Probably it's good enough, I'll try that anyway. So here's the fun and messy bit. I'll get back. Okay, I think I got one out. Well, I got one out, but will it work? I couldn't use that, I couldn't get it out of there. I used the mop handle that fitted in there, but it was just so hard. I ran out of strength and then it broke in half anyway, so I rolled that one. But that will probably snap in half. And it still may crumble. Hopefully it doesn't, but that looks like the part. I'm so lucky I didn't throw out my old fuel tank cap, because that fitted straight in that pipe perfectly, as you can see where I pressed it. So sometimes it does pay to keep things, because without that fitting perfectly it wouldn't have come out, because that was the 3rd time I tried getting that out, and then I found that made life easier. So it's all intact. It's a bit smaller than 100, but not by much. That's 100. That's about 80 mil long. All resides on that piece there. Carbon center negative electrode. That's got to hold together. Or we'll have to find a bigger tube which goes around that one maybe, with a hole in the center as well. That could work, because I guess that shape there is actually holding the carbon together. So I'll clean up. So actually it felt better with the corn flour mixed in water than it did with the dextrin. It was a lot thicker though, so maybe you have to go thick. But no point making dextrin, because you have to put that in the oven, mix it with vinegar and everything else, and it's a waste of time. Might as well just go straight with the flour. I forgot to say, the next stage we'll be putting it in the furnace and cooking it for 4 hours at 1000. So it's got to survive that stage yet. It's quite easy rolling that out. It was much easier than doing it that way. I loaded that up with the extra cornstarch as well. Okay, so nearly at the end of the 50th run cycle on this cell. So somewhat down, but still not too bad for what's in the cell actually. So I'll describe what's going on in the cell. The cell's one of those redhead bricks, carbon briquettes. It was furnace at 1000 degrees, as I use those as a to keep the oxygen down. I had some stainless wire. It's about 0.5, which is wrapped around the outside of the positive one, and for the negative electrode, it's essentially one of those briquettes which I chopped down the side and made one of those little things. That one's a bit longer. That one was the original one, but it was coming loose at the top there, and then I broke a bit off the bottom. What you do next is electroplate that with some zinc. I did it in zinc sulphate, and having one use a piece of this size zinc, which came out of a lantern cell, so it's only got that much zinc on it. I also put 1 gram of zinc oxide just straight down the center of the hole. The electrolyte is potassium hydroxide, 6 mol, and so with the positive round carbon cookie, that was first dipped in zinc hexacyanoferrate and then allowed to dry, and then I also dipped it in the nickel hydroxide when it was a wet solution, and it also sucked up some nickel hydroxide, and then when I placed it into this, it had some nickel hydroxide on the outside as well. I scraped most of it off, but it was still stuck there. After the first charge, all of the electrolyte went black, so I guess it's converted it to nickel hydroxide. And the center, that screw there is one of these. It's a 316 stainless steel screw, 65 millimeters long. Screwed down the center. I think it's okay, but I reckon the wire around the outside will be much better. So I purchased some 316 threaded wire, stainless wire. Where's the end? There. You can sort of see how fine those strands are. They'll probably bond a bit better, so I'm thinking 2 of those strands wrapped around as a collector will be better than that thicker wire, and it won't damage these as much, because when you start twisting them up, it can break those bits of carbon because they're quite delicate. But as you can see, it does charge up and discharge quite well for having a minimum amount. So it's only got a piece of that zinc plate plated onto the carbon. Most of it's at the top there as well, so that's unused. Separator issues. Yeah, because there's lots of nickel hydroxide, oxy hydroxide floating around. It attaches to the membrane and becomes conductive. Not very much, but it's in the 200 ohms. I tested that piece. That piece there fell off. That tracing paper seems to hold up better, but I'm thinking a hair roller with the electrode in the center, that should keep it pretty safe from touching anywhere, and you don't need the separator, which keeps getting clogged up, which may be the issue of the cells failing or losing its power. It's still quite high for 1 gram of zinc oxide, smidgen amount of nickel hydroxide, and another smidgen amount of zinc hexacyanoferrate, whatever would have absorbed into the carbon, is all what's in that cell. I was hoping it would be cheaper to make, but those cells, those electrodes come broken most of the time. That seems to be a pain to make those electrodes. It's like really hard and laborious, and I don't think it's going to actually work. I might try flat version with the plastic coated collectors. I'll plate one side with zinc, and then we'll make some binder and stick some carbon, and well, I don't know how that's going to work. No, this negative one will have to just be plain zinc coated, and the positive one can have some zinc hexacyanoferrate and also some nickel hydroxide added to the carbon, and binder will be the conductive ink. Very minimal amount of conductive ink. I've only used like a smidgen of 1 litre, and I've done a bit of stuff with it. When you coat your plastic, you'll probably need to stick some copper contacts at the top so you can drill a hole through there and put some bolts and not damage the ink with the alligator clips. So that's what I'll do. I'll drill a hole through those. I put 2 wraps of this 8mm. It said it was 100 on eBay by 50 meters, but it wasn't 100 by 50 meters, it was 10 by 50 meters. So it was a bit false advertising, that one, but well, still, I used it. So the resistance on these is really good. It's like 4 ohms from up there down to there, and that's over 140 mil long. That was dipped 6 times. So as you can see, it looks like the nickel hydroxide, oxy hydroxide is really stuck around the outside on the top layer of that cell. It is pretty beefy, 100 milliamp load. Alright, signing out. I'll show the discharge of this when it's finished, and I'll set up the video. We're still at 240 milliwatt hours and 209 milliamp hours, so it sort of holds up like that. I'll keep it around that cell, and I'll put a new separator in it and test it periodically, and I'll also give those alligator clips a good cleaning, clean that top piece, and we might get, oh actually I might clean it and solder some wires onto both ends, providing I can get enough heat in there, make a solder stick, and that should alleviate most of the issues. Some of the other issues are wobbling around the electrodes when connecting the leads. Really need to be attached properly. So the only thing with this one is it evaporates a bit. Doesn't bubble too much with 2.7 volts going into it. There's only like, probably see those little bubbles there? That's how many bubbles you get. You don't really see much for 2.7 volts. I thought it would bubble a bit. It does take like 1 to 2 amps through the cell initially on a charge. I'll give it another charge after this, but I'll just show you the charge curve and then I'll post that video. So we'll wait till it gets down to 0.7 volts. So far it's been working really well. Okay, as I thought, the carbon rod thing ain't going to work. See the cracks forming already? It's just going to break off. That piece may survive. That will be long enough for the cell. And maybe some other part, but I'm pretty sure it may probably crumble. Okay, the cell's reaching the cutoff voltage of 0.7. I should mention, the first 20 charges, I varied the charge from 4 hours, 2 hours, 3 hours, 3 hours, 4 hours, 5 hour charge, but seems you don't get much out of it on 4 hours, 5 hours. So I've limited the 30 charges to 2 hours and at 2.7 volts. And our run time for capacity is 251 milliamp hours. Energy density is 277 milliwatt hours. Average voltage 1.1, which is good because the average voltage is up. You could probably take the cell down to 0.5 maybe. Not sure. The reason for the carbon center electrode on the negative side is if we use zinc, we get more power, but we will get electrode shape change. On the discharge, it could just cut straight through there and you'd lose that half, or it could even just cut straight off up there. And then your cell's knackered. So with the carbon substrate as the collector, you can coat that with zinc and it will keep forming. And I think because it's circular, it plates pretty evenly down through the center with the zinc, where they'll, if it's a flat cell like that, you get uneven zinc plating. I tried one of these rods, no good. Couldn't even draw 50 milliamps out of it. So they are definitely better, but they're very fragile, hard to make, and getting good contacts is another important thing. So after this charge, we could kill it now, bugger it. So that's what the cell looks like, the negative cell. See, it strips all of the zinc off it, goes back to carbon. Well, you might be able to just see a little bit of grey area there where there's still zinc, and no zinc through there. I'll give that a clean. And the positive one, the stainless wire seems to be holding up on the outside pretty well. Yeah, I think the separators fell out through the bottom of that now. Got to be careful because it's nickel hydroxide, carcinogenic, and plus 6 mol of potassium hydroxide. So what I'll do before posting it, I'll soup the cell up a bit because I always wanted to see what happens if I put another gram of zinc oxide in the cell. Got a new separator, tracing paper will do. I'll clean the contacts, settle that up, add 1 gram of zinc oxide, stir it up and give it a good charge, and then I'll get back and film that one, and then that will be the last. Video's getting a bit long. The cell itself has been around for around about 2 months or more. Average only charge it once a day because of work and everything. I've only just today and yesterday and the day before because we went into lockdown, but it's been cut short now. I'll go back to work tomorrow, so yep. Okay, the cell was on charge for 4 hours today at 2.7 volts. Just started 100 milliamp load test. This is after adding an extra 1 gram of zinc oxide and a new separator. So it just came off a charge, so it's not very bubbly for 4 hours at 2.7. You can see where it's splashed up there. I cleaned them. So it does spray a bit. Okay, so we'll see how long it runs with an extra gram and a new separator. Okay, so the run with the extra gram of zinc oxide, 3 hours, 11 minutes, 320 milliamp hours and 373 milliwatt hours. So might just be the separator, maybe having a better one of them. Doesn't discharge as easy, but it's not much room between the electrode. So I'll give it another test because I'm waiting on some of those carbon briquettes to finish off this video. So after work tomorrow it should be charged up. So we'll see what it gets then. Okay, it's been on charge for 3 hours and 15 minutes. Just finished work. It's off the charge now. It's holding 1.9, starting 100 milliamp load. Second charge with the extra gram of zinc oxide. It's looking good. I'll get back. Okay, this was the cornstarch one. I think it's good. It did crack there, but it didn't go all the way through. That was the cornstarch rolled up one. It's got cracks in it, but it's okay. And then I made 3 others with a half a cup of graphite added to it. So, and this was with the flour. So we got larger cracks. I sort of like the other one, the corn flour one. So I got 3 of them. I think I made the mix a bit wet, and when I was pulling them out of the tube, they sort of compressed. So look at the holes. I'll just have to file them out. Later today, I'm going to furnace them to 1000 degrees for 4 hours. I made up that, but it broke. That's with the flour and graphite. So I'm gonna make some more after I fire these with corn flour and graphite, as well as the carbon. This is a lot better binding. It feels a lot harder. This one feels fragile. So I reckon the corn flour is actually a better binder. So something worked out. So they're much larger. Excellent. Got the large hole. See, this one held its shape when I pulled it out of the mold. And it's nice and porous. So we gotta hopefully they survive the killing process now at a high temperature. Okay. While I'm also talking about the furnace, I'll put some microfiber cloth in there to carbonize that. So make some carbon felt out of some microfiber cloth, and that's about it. Okay, got it in the furnace. So I'm going to leave it in there as hot as I can get for 5 hours. That's the homemade torch. It's worth looking up on eBay, YouTube, how to make one of them. All you really need is to buy a good decent regulator for LPG, and any old can or drum, and wall plaster and sand work alright as a refractory. You just have to replace it after 10 to 15 burns at super hot, which is not that dear, and that will get you by so you can make your briquettes. I made that with some fittings, a bit of welding, and I put a one-way gas valve just in case, or a flashback arrestor I should say. Alright, so that'll appear on the next video. I packed them with crushed carbon as well around everything. Put a bit of urea in the bottom, like I don't know, about 2 tablespoons worth. I have a microfiber cloth at the bottom as well. And then I buried everything in as much fine carbon leftover stuff I had laying around to keep the fumes down. It's been burning for 15 minutes, so nothing coming out yet. I can sort of smell some weird smell, but not urea. Okay, so back with the cell, which had 3 hours and 15-minute charge, 2 hours and 55-minute runtime, 293 milliamp hours and 344 milliwatt hours. So not too bad. Might in a couple of days add another gram of zinc sulphate oxide and see how it goes. So we have to sort of do some researching on separator techniques for this cell to improve it, because I don't think the paper's cut it in the long run. It's been around for a month. It sort of consumes paper like it's going out of fashion. Alright, so this will be the last bit of the video. I'll post this and keep updating the research. So thanks for watching.